Now this is a new area. Guys like Panavision and the Genesis and a lot of them now. I'm listing here all the cats that are out there with single imager cameras. And they will talk about their pixels here. And generally they'll say, my chip has these numbers of photosites. And then you have to try and deduce, well, what does that mean? Very, very difficult to deduce that. They break into two camps. There are those single imager cameras that are HDTV in their primary delivery. Genesis, for example, its primary digital delivery is 1920 by 1080 HDTV production standard. The 2/3 inch silicon imaging delivers a 1920 by 1080. ARRI will deliver you a 1920 by 1080. There are the other cameras that are, they call themselves the digital cinema cameras. They don't like to be labeled HD per se. Now some of them do, in addition, deliver a derived 1280 or a 1080 HD. But they're saying, no, we're going to give you a 2K delivery or a 4K delivery. And that's where some of the confusion comes in. They talk about these photosites, and then they talk about what I'm actually going to deliver is the digital. And you have to scratch your head and say, but what is the resolution? No information that I found published on that. So to look at the issue, I'm not going to pick on any of these guys. I'm going to pick my own set of numbers, very similar to some of these numbers, but different, a little bit different, just to be agnostic. And I'm going to use the Bayer, and I'm going to pick a 16:9 aspect ratio. This is my sensor, my photosites. So I'm slotting it in here relative to the others here. And we're just going to look at that. I'm sampling with this optically. I'm going to convert it into the DCI 4K, and that'll be my handover, a 4K digital handover. So in other words, this is my sampling, and this is my handover, and according to the DCI spec for 4K 16:9 aspect ratio, the digital samples must be these numbers here, by definition of DCI. I have to have red and green and blue delivered at that digital sampling structure. I want you to first look at, we're getting a close-up of the Bayer sensor. The Bayer sensor, the photosites on that sensor have this structure, and you'll see lots of greens, a quincunx of green, 2 reds, 2 blues. Now if you break that apart to look at them separately, you'll find the green is structured like that. It has half the number of samples. 4096 was in the total sensor, but half of that horizontally is green, and half of the vertical is green. It's an odd structure. You look at the red, it's what we call a classic cardinal structure. It's reds, vertically and horizontally. It doesn't have that quincunx look. But there's big gaps between the red. That fill factor is very big in the red and also in the blue. So the red and the blue have the same structure, have the same photosite count. The green has a different structure and twice the photosite count. Bayer is very clever. I marvel at it because really what Bayer is, it's diagonal sampling. Now what's that? Well, look at that and just turn your head 45 degrees. Now you'll see what the trick is, and it's very clever. It says, look, those pixels that had gaps between them when I looked at them horizontally and vertically, if I look at them diagonally, I've got a continuous stream of pixels. And by the way, I've got 4096 pixels back again. And vertically, I've got my full 2160 pixels. Now, this is not intuitive. What that does, and by the way, the shape, it's a rhombic shape pixel. And it's a peculiar fill factor between them. What all of that adds up to is it gives you the beans in terms of that 4K photosite sampling. You get the full benefit horizontally and vertically, but you lose diagonally. That's not intuitive. You would sort of think diagonal sampling, it's got to favor diagonal. I don't have time to go into the mathematics of it here, but there's lots of stuff written about Bayer. But it's very clever to have one sensor be able to give you a really good green and red and blue. But it is because of that broken blue having the half samples, it really is a 420 optical sampling system. And you now have to reconstruct that, from that, your red, green, blue, with a certain resolution. And the dilemma is the following. You've got the green with a terrific resolution. You've got a red and a blue, we're looking at the optical sensors, with half that resolution. Now you've got the aliasing problem. This is the aliasing for the green. This is the aliasing for the blue and red. You got one sensor. You've got one shot at an optical low-pass filter. What would you design it for? To favor the green or the red and the blue? If I put it here like this is my optical low-pass filter, which gives me a good green and some degree of aliasing control. That same filter would apply to the red and the blue, gives me terrific red and blue, but a whole lot of red and blue aliasing. All right? Can't live with that. Other option, put in a low-pass filter which really clobbers the red and blue aliasing, leaves me a respectable red and blue response, but look what it does to my green. Clobbers my green. What I would do is find something in between. You've got a fundamental dilemma here that you do not have in the 3-chip camera. So find a compromise. Put a low-pass filter in somewhere in the middle. Live with a certain amount of green aliasing and a higher amount of red and blue that you will find on test charts real easy. But the real world is pretty forgiving, actually, in terms of what it throws at a lens and a camera. And you may or may not find this. But you got to still ask, but what is the resolution of these cameras? How much MTF are they delivering? Not published. Not published at all. So now let's make the conversion to digital. Let's say I take that horizontal, the DCI container. DCI, by the way, their nominal aspect ratio is this peculiar number here. 16 by 9 is 3840. And this is where I'd get, if I design that optical filter to be compromised in here, my digital output in TV lines per picture height would be a pretty good green up to 2160 with some aliasing, and a very good red-blue up to 1080 TV lines with a lot of aliasing. And that's really the issue of the single sensor Bayer. Now these guys took another approach to the single sensor that I'll let John talk about. But that's the issue. And when you're testing these cameras, you need to be cognizant that somewhere in there, there's a compromise. But to simply say that because they are delivering 4096 by 2160 digital pixels, it's not telling you anything about what they've actually ended up with in resolution.